Okay, another way to determine inverse of the matrix is the adjoint method. Okay, now, okay, we define now the cofactors of an element of a matrix is defined as the signed minor of the element that is -1 raised to the I plus j times the minor. The minor of an element is obtained by evaluating the determinant that results from removing the row and column and corresponding to that element. Okay, now here our inverse of a matrix will be equal to the adjoint of A, okay, adjoint of the matrix A divided by, okay, the determinant of A, okay, the determinant of A, where the adjoint of A can be found, okay, can be found by what? By doing this method. The first step is to get the minors, okay? So what are your minors? 1, 1. Delete this and delete that. You will have what? You will have 0, -3, 1, 1. Okay, that gives you, okay, that gives you what? 1, and then 3, that is positive 3. Your minor 1, 2. Delete this and delete this. The determinant is 2. Okay, the determinant is 2, -3, 1, 1. Okay, that gives you 2. 2 plus 3 is 5. Alright, what is minor 1, 3? Delete, you have what? 2 minus 0, or just 2, 0, 1, 1. Okay, that gives you what? That gives you 2. Okay, minor, okay, minor 2, 1. So what is your minor 2, 1? Delete, you have what? -2, 3, 1, 1. This delete and delete. So you have -2, this -2 minus 3 is -5. Minor 2, 2. Okay, what? Minor 2, 2. Delete and delete. You have 1. Okay, 1, 3. Delete. 1, 3, 1, 1. You have 1 minus 3 is -2. Minor 2, 3. Okay, delete this and delete this. You have 1, -2. 1, 1. You have 1 plus 2 is 3. Alright. Minor 3, 1. So delete and delete that. You have what? -2, 3, 0, -3. You will have 6. Minor 3, 2. Okay, you have what? This and this. You have 1, 1, 3. This and this. 2, -3. You have -3 minus 6 is -9. And the last is minor 3, 3. Delete. You have 1, -2, 2, 0. That will give you positive 4. Then you will have to find the cofactors, okay? So your cofactors, alright. Now remember that your cofactor, okay, of ij is equal to -1 raised to the I plus j of minor ij. So this one will, if the sum of these coefficients is what? Is even, the number is retained. Otherwise, the number is reverse the sign. Okay, so minor 1, 1. Let us get the cofactor of matrix A. So this is just 3. This is 1 plus 2 is, it will be reversed. 1 plus 3 is 4. Okay, so it's positive. 2 plus 1 is what? Negative. 2 plus 1 is odd, so negative, negative 5, positive 5. 2 plus 2 is even, so negative 2. This is what? This is 1, 2 plus 3 is odd, so this is negative 3. 3 plus 1 is even, so this is 6. Okay, this is will be 9. 3 plus 2 is odd, and 3 plus 3 is the same as 4. Alright, this is the cofactor matrix. This is the cofactor matrix. Now, how do you get the adjoint of a matrix? Now, the adjoint of a matrix now, adjoint of the matrix A is equal to the transpose. Okay, the transpose of a matrix will just be what? 3, okay, 3, negative 5, 2, and then what? 5, negative 2, and then negative 3, and then 6, 9, and 4. Alright. This is the adjoint of a matrix. And then you have to find the determinant of A. Right. Your determinant of A can be found, okay, by what? By just rewriting, okay, by just multiplying, okay, by just multiplying the element. The original element is 1 times its cofactor is 3 plus negative 2 times cofactor 5 plus 3 times cofactor 6. This is 3 minus 10, or 3 plus 18 is 21 minus 10 is what? The determinant is what? 3 plus 18, that is 21 minus 10 is 11. Okay, I made a mistake, okay? Alright, the cofactors are here, and here is the cofactors because I get the adjoint already, okay? So this should be 1 times 3 plus negative 2 times negative 5. Negative 5, okay, plus 3 times 2. This is 3 times 2. So this is around, this should be multiplied then. So this is 3 plus 10, 13 plus 6 is 9. 19. Okay, or you can also multiply that, the next one, 2 times 5 plus, this is 2 times 5 plus 0 times what? Times negative 2 plus negative 3 there, times negative 3. That's also 19. 19. Okay, so our inverse of a matrix now, okay, will be equal to, okay, the adjoint of A divided by the determinant of A, and that will give you just 1 over 19, and then what? And then 3, 5, 6, negative 5, negative 2, 9, and then 2, negative 3, 4. So this is our inverse of a matrix. Now let's verify that. Okay, let's have menu. Okay, and then 4 again, and then define matrix A, but this time it's gonna be a 3 by 3. 3 by 3. Alright. Let's have this as 1, negative 2. This one, 1, negative 2, and 3. 2, 0 and negative 3 and then 1, 1 and 1. Okay, you can get the inverse matrix right away here. Just enter option and then matrix A raised to the what? Raised to the uh, just write the x is negative 1. So you have matrix A, look at that. I have 3 over 19 there, 5 over 19 there, 6 over 19 there, okay, negative 5 over 19 there, negative 2 over 19 there, 9 over 19, 2 over 19, negative 3 over 19, and 4 over 19. Okay, so what I did is only the joint method. Okay, so there are other ways to determine inverse matrix. One is the Gauss-Jordan